when we introduce the log. So you've graphed a bunch of exponentials. Log is going to be an inverse of an exponential. So this says find the inverse of the log function. So here's what we're going to graph. I'm just going to find the inverse real quick. So if you guys remember how to find an inverse, just algebraically, this will take like 2 seconds. You switch x and y. So I would write x equals the log base 3 of y. And you get y by itself, or solve for y is how they will word that. So all I need to do here to get y by itself, I'm just going to convert this from a log to an exponential, and this will look maybe a little bit backwards from what we've been doing. But if I get rid of the log, the base of the log becomes base of an exponent, so that 3 is going to swing across the equal sign and push the x up in the air, and I'd have 3 to the x equals y, which I wrote right over here for you guys because we're going to make a table for that. So the inverse of log base 3 of x is y equals 3 to the x. So it's an exponential. It's the inverse of a log. So because we can graph the exponential no problem, I just picked a basic table. So it's just 3 to the x. It's good to get a couple positive numbers, couple negative numbers, and 0, and then we'll just plug these in. Some of these are going to be decimals, so we're just going to do our best to put these on the graph. So like if I plug in -2, I'm choosing the x values to plug in, right? If I plug in -2, that'd be 3 to the -2, this guy'd be 3 to the -1, 3 to the 0, 3 to the first, and 3 to the second. So I'm choosing those x values. Now, I'm going to start from the bottom of the table and write these down, right? 3 squared is 9. That's a nice number. 3 to the first would just be 3. What's 3 to the 0 power? 1, right? Anything to the 0 power is 1. That's going to be helpful today. And then, now, don't forget, negative exponent does not mean negative number. It means fraction. So 3 to the -1 is 1 over 3 to the first, or just 1/3. This guy would be 1 over 3 squared, which would be 1/9. If you would prefer to write that as a decimal, that is completely fine with me. But just for those points, just do your best to kind of estimate. It doesn't have to be perfect. I'm just going to estimate where that would be on the graph. So I'm going to come over here just real quick. At -2, I'm just like barely going to come above the x-axis for that 1/9. And then for the -1, I'm just going to go just like a tiny bit above that. And then the rest of the points will be nice. So 0, 1 is a nice point, 1, 3 is a nice point, and 2, 9 is a nice point. It's like way at the top here. And I'm not on the screen, so let me pull that down a little bit. Oh my gosh. Fail. Now, do you guys remember this makes like a J shape? Now, if I keep on plugging in negative values for my exponents there, remember that actually never becomes negative. The fraction gets tinier and tinier, and it would be really hard for us to graph that because it's like infinitely close to the x-axis but doesn't actually touch it or go over it. So that would be my general shape of an exponential there. And let me I'm going to draw in the asymptote for that exponential. It would be the x-axis. Okay, now, sorry guys, I made this too big. Let me zoom out on this and see if I can just see if you guys can see this. Okay, all right, so what I'm going to do, my domain for that, right? And it looks like it goes up really fast, but it does go left and right forever. It just goes over to the right. It goes up really fast, so it would go over to the right very slowly. So the domain for any exponential function should be -infinity to infinity. Or if you prefer, if you want to write all real numbers, I'm totally fine with that too. That just means the same thing, just a little shorthand for that. Now, what is my range for the graph that I have on there? Do you guys remember how to write the range? Eli, what do you think? 0 to, now this one I'd have to write an interval because I can't, they don't have a letter to represent that. But you just have a parenthesis around the 0 because we don't actually touch that asymptote. And I highlighted it on the graph, but the asymptote for any exponential function is horizontal, and I call it horizontal to remember it. So just be y equals 0, which is the actual equation of the x-axis, but it's all those y-coordinates are 0 on that little blue line that I highlighted there. Okay, now what we're going to graph is going to be the log, and it is the inverse of an exponential, and this is up in the little directions up there, but this little dotted line here, if you guys remember, for any inverses, they are a reflection of each other over the line y equals x. So it should be, if we folded these graphs in half on that diagonal line, they would match up. And so I've just put that in there so you guys can see that, but I'm going to actually come over and I'm going to go ahead, and if I have the table for this exponential, which is the inverse, we can just switch it and use that table for the log function. So I'm not moving anything around, we're literally just transferring the x and y coordinates. So if you have the inverse, we're just going to switch these. So this would be 1/9, 1/3, 1, 3. It's a little bit harder to choose the x values when you have a log function. Like if I had a log base 3, what I'd want to put in for x is something that would be like a power of 3. But if I just do the table like this, it's a little bit quicker. And so we're going to come over here. These are really tricky to graph. So for my x value of 1/9, I'm just going to like barely come to the right of the origin and then go down to -2. And then for the 1/3, I'm just going to go over a little bit farther and go to the -1. Then the rest of the points will be nice numbers. So you'll have 1, 0. You'll have 3, 1. And then you'll have 9, 2. And this will give you guys an idea of the general shape of a log function. Okay, now, you cannot take the log of a negative number, and you cannot take the log of 0. So this kind of like J shape is going to kind of hug around. It's not going to go over the y-axis. It's going to look like this. And for your log function, the asymptote is the y-axis. So the log function, and if you guys remember this from when we did inverses, the domain of the original should be the range of the inverse. The range of the original should be the domain of the inverse. And that's totally true here. If you look at your x values, you don't start touching that log function until you hop over the y-axis, which is the equation x equals 0. I can't actually take the log of 0. If you try to do that on your calculator, it's an error. There's no value for that. So again, we just have a parenthesis here, and it's going to go after we hop over that y-axis, and then it goes to the right forever. So it goes to positive infinity. And then this also, it looks like it kind of levels out, but this does go down forever, and this gradually, this kind of the branch here that's going to the right, it goes really slowly, but it does gradually go up forever. So you would cover all the y values on the graph, so negative infinity to infinity, or if you want to put that all real number symbol, I'm totally fine with that. Anytime you have a log function, the asymptote is going to be a vertical asymptote. Maybe I should draw a little tiny picture here. So horizontal is flat like the horizon, and vertical is going to go up and down. I call it vertexal to help me remember. It's going to be x equals the number, and for that function, it's just going to be x equals 0. Is anybody having a question? Okay, now I'm going to kind of show you down here how to cheat on this. Excuse me. All right, so and this is kind of hard to see because these graphs, they don't really have good grid marks on them. But I just have a basic log function, and it's going to take this general shape and pretend we can use function notation, or you could think of this as y equals the log base b of x. Now, what's going on there is every log function, it's not shifted or anything, just basic, just log with a base of x. I'll show you how to shift it on the back. But it always goes through the point 1, 0, and it always goes through the point, whatever the base or the little subscript is, and 1. So those 2 points are super important. And what I want to, let me pull this graph back down, and you guys will see right here. This goes through the point, right? 1, 0, Like we did that all by hand. And then it also goes through the base of this log we did up here was base 3. It goes through the 0.31. Those are going to help you get a good idea of these graphs when we have to shift them. But they always go through the 0.10 and then whatever the base is, 1. So let me prove to you real quick why that works. So if I come here to this graph, if I plugged in for x, the x value, right? If I do log base b and I plug in 1 as my x value, my y value is supposed to be 0. So let me just show you. I'll just do a little quick convert this to exponential form, right? This base b to the y would have to be equal to 1. What does y have to be to make that true? 0, right? Anything to the 0 power is 1. So that's the argument for why you're always going to have the, if you plug in 1, if you ever take the log of 1, it's always equal to 0 because that's the only way to get an exponent to give you a 1. It has to be to the 0 power. Same argument, if I do, excuse me, y equals log base b, and then let's say we plugged in the actual base, right? If I convert that to an exponential real quick, I would have b to the y equals b. That has to be, those bases match, so it just has to be the first power, so y would have to be 1 in that situation. If you guys remember talking about this yesterday, anytime the base and what you're taking the log of match, that is always equal to 1. And so that's why that y coordinate is 1. And you guys could see right here, this is more, a little bit more specific. This is, and if you want to think about it, log base 5 of x. And so you see the 2 points, you see 1, 0, and you see 5, 1. And we could make the same arguments. If I want to plug in 1 here, that would give me a y coordinate of 0. If I want to plug in 5, we'd have log base 5 of 5. Now, the next point that would actually give you a nice value on this would be 25. Like if I did log base 5 of 25, which I'm not going to have you guys graph on here because it wouldn't fit, but if you had that, what would my y value be? Anybody know? If I plugged in 25, what would the y value be? What do you think? It would be 2. So you do 5 to the y, so this would be 2. So you can see on these graphs, like the next nice point, if you will. We have other points in between here, but the next nice point that I could do would be way to the right there. So I'm just going to have you guys graph 2 points when we shift these around, the 1, 0, and then whatever the base is, 1. So this is just an example with 5 as the base. All right, now the shifting, which is what we're going to do here, works exactly like it does for all the other types of graphs that we've worked with. So if you have log base b of x and we shift it, and we're going to use h and k here again, whatever is inside with the x, this is going to shift your graph left or right and the opposite way that it looks, because it's what's going to set that equal to 0. Whatever is outside, that is going to shift your graph up or down, and you would just copy down whatever that number is. So I'm going to show you guys how to do these real quickly. The left or right, I'm going to write, we're going to move the y-axis. If I move left or right, because remember the y-axis actually has the equation x equals 0, so the x is going to move left or right, it'll move the y-axis. If you move up or down, you're going to move your x-axis to do this. And then we're just going to plot points. It's not going to be hard, I promise. The one thing I want you to remember for these questions, just in general, can't take the log of 0 or a negative number. It's not defined. You can't take the log of a negative that doesn't have a solution. You can't take the log of 0. If you try to do that, no matter what the base is, if you try to do that on your calculator, it won't exist. So the graph doesn't exist where you would be taking the log of a negative number or 0. Okay, so I'm going to show you how this works. This says we're going to, on the graph, I just have y equals log base 5 of x, so you guys can see that. We're going to shift it. So whatever is inside with the x, this is going to go the opposite way that I think. So when I see that, I see a +2. This is actually going to move -2. So it's going to go 2 to the left. Now, if you go to the left, what we're going to do, I'm literally just going to move the y-axis. So think about the origin. I'm just going to go 2 to the left, and this will be easier on the homework and the rest of the notes down at the bottom because I have actual grid marks on there, but I'm going to scooch my y-axis over 2 units. Okay, now whatever is outside, that looks like a -4 to me, so I'm going to keep it as a -4, and this would go and move everything down 4 units. So we've got a diagonal translation here. So with the down, what I'm going to do is I'm going to come over here, scooch this up a little bit so you guys can see it, and just do my best to try and draw a nice horizontal line at -4. Okay, so there's a couple ways that you can do this, but probably the easiest way. Pretend this is your new x and y axis. Every one of these graphs would have the point 1, 0, and then whatever the base is. In this case, our base is 5, so 5, 1, if I have a base 5. What I do to shift this is literally just go to that new origin that I created with those little rules in place. So I went left 2, down 4. Just from here, I would go and graph the point 1, 0. So on this actual graph, that would be the point, here I'm going to write it up here, that would be the point, let's see, -1, -4. So I'm subtracting 2 from the x-coordinate, and then I'm subtracting 4 from that y-coordinate. Or you could just do it right on the, I think it's a little easier, just shift the x and y axis, pretend that's your new x and y axis, graph the point 1, 0, and then 5, 1. So this would start with this as the origin, go over 1, 2, 3, 4, 5, and then up 1. So that would be the point 3, -3. So what I'm doing there, I'm subtracting 2 from the x-coordinate, 5 minus 2 is 3. I'm subtracting 4 from the y-coordinate, 1 minus 3, excuse me, or 1 minus 4 would be -3. Now, what I'm going to do, just kind of draw that kind of like sideways J shape. And that would be the general equation for that graph. Now, the domain is going to be different here than what I started out with. If I plug in -2 or anything smaller, that would cause me to take the log of a negative number or the log of 0, so the graph isn't going to exist over here. So you don't start getting points till you hop over that line x equals -2. So for your domain, it should be -2, and then it's going to point to the right forever. Whatever you used as your number for your domain should match with the number for your asymptote. So the asymptote's just going to be whatever sets those little parentheses equal to 0, and it's a vertexal line, it's a vertical line, right? We can't go to the left of that because then we'd be taking the log of a negative number, so it should be x equals, in this case, -2. Now the range, every single log function should just be -infinity to infinity. Don't think about that one too much. Does anybody have a question? Okay, I'm just going to shift one more with you guys. So inside with the x is going to go the opposite way that it looks. So to me that looks like a -3. So this actually goes 3 to the right. So what I would do on my graph, I'm just going to take my whole y-axis and I'm going to shift it over 3 units to the right. And forgive, I know it's tricky on this graph because there's no grid lines, but I would just have a nice vertical line at 3. If I were to plug in 2 to that original problem, we'd be taking the log of a negative number. So there should not be any graph to the left of that vertical line I just drew. All right, now the other shift here, I have this +1 on the outside. So this looks like a +1, so it is going to stay a +1. So this is going to shift your x-axis up 1 unit. So I'm just going to come over here on the graph. Just 1 unit. And we're going to pretend that's our new x and y axis. So every single one of these has the point, bless you, 1, 0, and 5, 1. So it still has those points, we're just going to shift them. So pretend this is my new x and y axis. So the point 1, 0 on this graph would actually be at 4, 1. you would add 3 to the x-coordinate, so that would be 1 plus 3 would be 4, so that makes sense. And then I would add 1 to the y-coordinate. The original y-coordinate is 0, add 1, that should be 4. All right, so for the other point, 5, 1, pretend that's your origin. You're going to go 1, 2, 3, 4, 5. You'd be at 8, and then you go up 1. So that would be the point 8, 2 on that graph. And then just get real close to your asymptote, and I'm just looking for those 2 points in that general shape. Domain here, okay? If I plug in anything that is 3 or smaller, that causes us a problem because we'd be taking the log of 0 or we'd be taking the log of a negative number. So it should just be that vertical line to start your domain. Don't actually touch it or go over it. So 3 to infinity, range, negative infinity to infinity. And then your asymptote should just match up with the vertical line there, nice vertexal line. So x equals 3. If I plugged in 3 or anything smaller, that causes us an error message on the calculator because we're going to take the log of 0 or a negative number. It's not defined. Okay, is anybody having a question? Okay, I'm just going to scooch this up. Now this, I hope this will be way easier to do because this actually has a grid on it. Okay, now this is going to shift the log base 4. So I just want to write these real quick. The log base 4, all of these would have the point 1, 0, and then whatever the base is. So the little subscript here is 4, so it'd be 4, 1 for these graphs. So it's a little different than the one we just did because it's a log base 4 instead of a log base 5. Okay, now I'm just going to have you guys read this equation. Just tell me how this would shift the graph. So this one just says log base 4, and then I have x minus 4. Just raise your hand and tell me how would that shift just a plain log base 4 of x. Say that what? It would be positive 4, 0. Yes. Okay, so there's nothing on the outside. So we're just going to go left or right here because we've got it on the inside. So this would be positive 4. So if I were describing that, I would just say like right 4 if it asked you to describe it or whatever. Okay, so we are just going to scooch the y-axis over 4 spots. So let me grab a highlighter instead of this. So here's my new y-axis. Would my x-axis change? No, you don't have anything moving it up or down. So the x-axis is just going to stay the x-axis. So all you got to do, pretend that's your little origin right there. You're going to graph the point 1, 0, which will be way easier to do because we actually have grid marks on here. And then this one had a base 4. So the other point from that pretend new origin, we're going to go 1, 2, 3, 4, and up 1. And then I'm just looking for that general shape. Now, the domain should start up with whatever that vertical line is, because if I can't even get the equation on the screen at the same time. If I plugged in 3 to that original problem, that would be causing me to take a log of a negative number. So there's no graph to the left of that vertical line. So this should just be parenthesis 4 to infinity. The range, I know it looks like it goes really slowly, just negative infinity to infinity, or if you prefer, you can go ahead and write all real numbers, whatever you like better. And then the asymptote. Now I know I'm drawing an x and y axis to graph those points, but the asymptote is only the vertical line. So it's going to be the x equals 4. The y value, and you guys will see, the x-axis is not an asymptote, right? Because I literally have the graph going right on that line. So the x-axis is not an asymptote because my graph actually crosses it. Asymptote is a line your graph crosses but doesn't touch or go over. So the graph is kind of bounded by that vertical line. It's not going to touch it or go over it. All right, now, go ahead. So the points, okay, it's actually not 1, 0, 4, 1 on this one. So on this one, it's the point, let's see, we'd have 5, 0. So any log function will always go through the point 1, 0. That's what we were doing over here. So like, I'm just shifting those points. So that's where they come from. So if you write those down kind of as your base 2 points, that's where you want it. So I know this basic one would go through those actual points. This one is going to go through those points like kind of in quotation marks, if you will, but based on the shifting that goes on. So it's just going to, So if I had the original one, here I'm going to graph it just real lightly here. So I'd have 1, 0, and 4, 1. This would be just log base 4 of x, not shifted. So this point, if I go 4 to the right, just goes over 4 spots to the right. And then the same thing here. This one just goes over 4 spots to the right. So it's just shifting it. I just didn't have you guys draw the original. Really good question. But always 1, 0, and then whatever the base is, 1. So this one has a base of 4. That's why I used 4, 1. Okay, how would you tell me I'm shifting if I give you log base 4 of x minus 2? How would that shift just a plain log base 4 of x if I have a minus 2? We're going up, down, left, or right? Yes, okay, no parentheses, right? So this is, and you don't have to put this in here, but this is just log base 4 of x, and then no parentheses there, so the minus 2 would just go exactly what it looks like, down 2. All right, so for this one, my y-axis is not going to move because I'm not going left or right. My x-axis is going to go down 2. So I'm just going to graph those 2 points that we were talking about, but based on my new x and y axis. So 1, 0 would be right here, and 4, 1 would be right here. The actual points are, let's see, 1, negative 2, and 4, negative 1. And that completely makes sense because all I would be doing there, whoops, I did not do a good job connecting that up. All I would be doing there is taking the y-coordinate and subtracting 2. So if I have 1, 0, and I take it down 2 units, it should still be 1, but negative 2 would be the y-coordinate. And if I had 4, 1, took that down 2 units, it would be 1 minus 2, so that would be the y-coordinate would be negative 1. So it just scooches everything down 2. Now, in this case, because I didn't go left or right, the y-axis is my asymptote, right? So the domain, excuse me, is just 0 to infinity. Because I'm just taking the log of x. So I can't plug in 0 or anything less than that, so there's no graph to the left. Your range, I'm just going to write all real numbers, and your asymptote would be x equals 0. And then I'm going to have us do one more here real quick. This has 2 shifts. So this one, it's opposite of what it looks like. So that 1 inside there, negative 1 would cause me to take the log of 0. So that's a problem, and anything to the left of that. So this is going left 1 unit. And then the plus 3 on the outside, this is just going to go up 3. So whatever's on the outside, we're just going to copy that. So I'm going to shift my y-axis 1 unit to the left. And I'm going to shift my x-axis up 3 units. And then I'm just going to plot those 2 points, 1, 0, and then whatever your base is, it's 4 for all these graphs, 1. So it'd be right here and right here. The actual points, if you're looking at the graph, if you want to jot them down, 0, 3, and 3, 4 would be the actual points. And your domain here. So I shifted it left 1, so the domain is negative 1 to infinity. Your range is going to be negative infinity to infinity, or the all real numbers. And then the vertical line, because I know I did a x and y axis, like I was just telling you guys there. The graph actually goes across that horizontal line, right? It goes across that, so it can't be an asymptote. The asymptote is only the vertical line, which is x equals negative 1. And I'm totally not on the screen. Fired. All right, is anybody having a question? I don't need, like, I think it asks you to do 2 graphs, actually, like we did that first example on the homework, where you do it by hand and make a table and everything.